what we're going to do, just quick intro about what is the smart contracts and distributed decentralized applications. What is the setup that you can employ to use JavaScript to communicate with smart contracts. And we'll do a quick demo of using one of the decentralized application to actually change some stuff and deploy it on the blockchain and see what are the future steps if you are really interested in that. So the current landscape of the tools and technologies is quite wide. That's why we won't deep dive into what is a blockchain or how the contract is compiled. All those details you can find later. So what I would like to achieve is that you can see that you can basically build your own blockchain application from scratch in quite a short time if you know JavaScript and you know how it works. So let's move on. Basically, who here has some slightest idea what a blockchain is? Please raise your hand. Okay, very good. That's what I was expecting to, so I won't start what it is. Let's just go directly to one of the most popular blockchain implementations. It's Ethereum. It's been started around 2015 by a guy, co-founded by a guy named Vitalik Buterin. You probably saw this person in the talks about decentralization, cryptocurrencies, and all that stuff. So it's open source, decentralized platform, and one of the key features why it's being so popular is that it features the ability to execute contracts, any code you would like, let's say, on the nodes of the network. So network of Ethereum has two types of accounts, basically. One is a user, which has ID, and address, and the funding. And the other one, is which makes it so different, is the contract address. Basically, it's an arbitrary piece of code which is attached to that address, which can be called by the user. And that's how basically the workflow starts. So user calls a contract, then the contract performs some actions, and this action, if it's approved by the contract, can be distributed throughout the nodes of the network, and each node validates it and adds it if it's valid to the blockchain. So what are actually the smart contracts? Besides the formal definition, which is a bit quite abstract, it's basically pieces of code written in a specific language which can be executed on the Ethereum network. Examples, again, you probably heard of those options to create a pension or a trust fund, network democracy, where you can every user can cast a vote, and in the end you see who basically choose which option, and all this information is being stored in the network. It's being transparent and validated by all the parties. Actually, the ICOs, so famous last couple of years, a lot of them, they use Ethereum as a platform because of the smart contract. Okay, so what it takes to write actually the smart contract. It's, as you can see, there's a specific language developed which is called Solidity. It wouldn't look very new to you if you used some object-oriented languages like Java or even modern JavaScript. You have basically options to import stuff from other reusable parts. You have the main structure, which is the name of the contract. You have substructures, which define the types of data which contracts works with. And you have methods and events, which can toggle the state of a contract, or let's say, get information from outside world or push it to the outside world. So here I have an example of a really simple contract which performs a to-do list where you can add an item, you can toggle an item to be active or inactive, and that's basically what we're going to do in the demo you will see later. So how does this code basically starts working? So the life cycle is relatively simple. When you compile your Solidity code, you have a bytecode which is being deployed to the whole network, to all the nodes basically. And after that moment, the contract has a specific address by which you can call it and call functions on it. And after that, you can interact with your contracts since it's being deployed. So one more level deeper, basically the decentralized apps. Those are the apps, like native or in a browser, it doesn't matter, who use as one of the APIs they work with, they use blockchain. So they use blockchain to store the data or retrieve the data. So this is basically the definition, but as you will see later, the apps is nothing more different than a normal one, besides the fact that you can employ the power of decentralization and blockchain. So if we want to write this decentralized app, how we're gonna actually connect to the Ethereum? So there is a Web3 provider, which is basically a wrapper on top, which can provide you connection to Ethereum network. You can see here the snippets of code which you may use in your app. Basically, first you connect to your provider, then you may set some defaults, some settings, select an account, and so on. And after that, it should look quite the same as you would be using, let's say, some Ajax calls or something. You just have your main object to which you call the methods on it. So you check if the status is connected or not. You may validate if this address is an address that you can actually do something, and then you can send transactions, check the balances, all that stuff. It is quite straightforward. As I said, connecting to a network. Basically, what is a network is the blockchain, right? There are different networks in Ethereum. One, let's say, production one with real money, and there are, I don't know, a bunch of test networks which are there just for developers to test their algorithms and for a variety of test purposes. And of course, for local development, you would prefer to have something running locally. For that, there are several tools. One quite popular was Ethereum Test RPC. And since last year, it's being acquired by let's say another company, and now it's called Genech CLI. Basically, it's your local Ethereum blockchain running on your machine, which you can use to deploy and to test your apps. And what is nice is that they have also a GUI runner, which we're going to use in the demo. You'll see later. So you basically know fancy console stuff. You'll just see transactions running nicely in a separate application. As I said, this Genech CLI is a part of a Truffle. Truffle is one of those projects that produce tooling for blockchain developers. And Truffle is also distributed as an NPM module. You can install it and then init a project with it. So basically, Truffle takes care of a lot of stuff related to creating an app which communicates with a blockchain. So it takes care of deploying your contracts, of compiling your contracts, and it also basically is a provider for Web3 that you use in your JavaScript code. So now just a quick explanation where is basically how it's happening, the interaction. As you can see, when a user clicks a button or adds some information, you just initiate a transaction which goes through the Web3 into the blockchain, let's say, calls the contract. Contract is being executed. If it's correct, you get this becomes a valid transaction, which is added to the list of things that needs to be mined. Here we come to the basic concepts of blockchain. And when the block is mined, all the other nodes know about it, and they add it as a set in stone information then that any other party, also your app, can validate, so retrieve. So basically, if I press the button, send the money to somebody, and I have enough money on my account, this transaction is being validated. New block is added where it says, I've sent the money to you. And then everybody in the network can see it, and that's just another block in the network. Now let's go to a quick demo. What I'm going to do, we'll take a simple to-do list app and then extend its functionality a bit. So basically, so I have here this Genech GUI runner. Basically, when it starts, it gives you two addresses. And as you can see, there are no blocks yet, no transactions. Everything is clean. Now we'll open the freshly cloned repository with this to-do app. What is it? It's basically a really simple React app. Is that good enough? You can see it? Fine? Okay. So it's a really simple React application which has basically list input field where you can add to-do, and then you have the list of to-dos, and then you can remove one of them one by one. So from UI perspective, it's really simple. But what is cool about it is that it, as you can see here, it employs the Web3 connector, and here you can see that it connects to the provider, which is running on our local host. This is the actual blockchain provided by Genech CLI. So here we connect to this provider, and then we have a couple of methods, such as get info from the contract and select a contract to communicate with. Also, valuable point to mention is that the config file, which is basically quite simple, you just can define some specifics about where is your blockchain running, on which port, or it's something not on your machine, that's also possible. So here it's really simple development setup where you have everything on localhost. Besides that, if we take a look at the app structure, we have basically here a folder for build files, some configs and settings. Here you have the contracts, which we'll take a look now. Basically, the SRC folder is just your normal JavaScript code as you would have in any other application, and the config file for Truffle specifically. So let's take a look at the contracts. So here we have, again, very simple to-do list contract, which I showed in the beginning of the presentation, which has only one specific structure, which is called a to-do item, which has a name and a current status. We can add it, we can list it, and we can remove it. That's the current starting point. Okay, so what we're gonna do now? We're gonna, so we have a, let's say, raw contract file, and to be able to execute it in the blockchain, we first need to basically compile it. As you can see here, I'm doing a compiling. After compiling, we have here in this folder, we get two, oh, wait a sec. Checked it before, but something didn't work. Is what they call demo effects? Yeah, of course. That's it's part of the story. Yeah. Yeah. So build contracts. Yeah, I think they're actually there. Yeah, I forgot to refresh. So in the build/contracts, we have those files, which is, as you can see, is specific JSON structure which defines a contract. Let's say it's intermediary between the binary compiled contract, which will be put into Ethereum, and something that Truffle provides you. So next step will be do the migrate. This will put the compiled contract into the blockchain. Fingers crossed. Here, okay, it worked fine, and we can see now in this GUI we had several blocks added and several transactions. Here you can see it. It's a contract creation. Unfortunately, this one cannot be zoomed, so you have to believe me if you cannot see this. We created a contract here, and this is the binary data of this contract, and this will be executed by the nodes of our small local network. Okay, and as you also can see that the balance, initial balance was 100 Ethereum coins, but the deployment took some cash, some imaginary cash from it, because this is an operation which also requires some processing power. So that's, you can see later it will decrease by each time we're doing a transaction. Okay, that was deployment of a contract. Let's take a second part, which is starting the UI. UI, as I said, is just a React application. It shouldn't take long. Here we are. So here we have this nice demo. Basically, it's now in idle mode. Let's add some to-do. Of course, let's add tests. So in the top right corner, you can see an indicator that this is actually connecting to the blockchain and deploying it. So add more tests. So, and also you will see that there are more transactions added here. Those two just happened now. And again, so there are more blocks mined. I'll just put it just next to this screen so that we can see how it's growing, basically. So we do, let's say, this. You see that there are more transactions in our small network. And now we can also remove, basically, stuff, which also takes transactions in our network. Also, this GUI tool has a detailed logging, the same as what you would see in the console. So that's really, I think, a good tool to start. Okay, that's a really simple to-do app. Normally, you would also have the option to basically check the mark and say, this is done. I finally added the tests. I can get a coffee and have fun. Okay, let's add this functionality. I will cheat a bit because I have it here. So basically, the extension of a contract is to add a toggle to-do item function, which will just pick the item by its index, invert the status, and basically put it back. And the change in the UI is just add another box which will be doing the toggling, like the check mark. So here I add a toggle button. I don't know if it's visible. Yeah, I think it's visible. Yeah, add a handler to it, and basically add some UI for it. Now let's apply this change. Okay. Now we will see here. Okay, since we changed the contract, now we need to also update it in the blockchain because it's still running the old code. For that one, we'll have to do again here basically compile the new contract. Yeah, and
question?
yes.
Old contract will stay forever in this
Yes. Well, until I shut down the GUI, it will be there. But if you talk about something outside your computer, it will stay there forever. Yeah, and that's actually a point when you, let's say, deploy something. You must be really 100% sure that things are working fine. Otherwise, you may lose real money, and that's the whole big topic of security of smart contracts. But there are ways basically to mitigate that. For example, you deploy one like a wrapper contract, which points to a latest version, and then later you add functionality or you cover some bugs, and then you deploy it through this wrapper, and the wrapper now points to a newer version. So the people, of course, found a way to deal with it. Okay, so now we do truffle migrate, but with a reset because we want to override the first version. Yeah.
Can you call external service from the contract?
External service, you mean what thing? What specifically?
Make a request so it will authenticate.
Well, you can do it from your app, or you want to do it specifically? No, from the contract you cannot call the, let's say, outside world. So the only way is that, again, some standalone app, like your JavaScript app or let's say your native app or whatever, can check the contract status, and there may be like a status like, I want to check the weather in Amsterdam. And then the app should do the call, and then give the contract the new information. Okay, in Amsterdam it's again raining. And then the contract will react accordingly. So contract itself is just fully limited in communicating to outside world. It can only answer when you call it that way. Okay, so meanwhile we've deployed the newer version. Now let's check what we have here. So since it's a new one, we lost all the previous to-do items. Let's add them again, right? Let's go to Meetup. So we have it here. It's not, now we got this new UI piece which you can toggle the item. And again, if we look at the transactions here, if now I check the mark, I basically get another call, which means I again toggle the information in the contract. Then do a presentation, add another one, get a beer, and so on. So now I almost did the presentation, so I can check that one. As you can see, the blocks keep on mining, and the transactions are all recorded. Again, if I stop now the network, it will all disappear. But thanks to Truffle, you can deploy those things to test Ethereum network, and really everybody can try to access it and play with it. Okay, that was a demo. Just some quick word in the end. So the demo I showed you, as you see, it's quite simple version of a contract and quite simple UI. But there's really a lot of tools and tutorials how you can enhance it and make your knowledge better. There is a special web IDE, which is called Remix, where you can check your contracts and validate them and even deploy them. There are also reusable pieces for your contract code. This is called Open Zeppelin, is one of most famous projects behind it. So basically the battle-tested, security audited code, which you can reuse the same way you reuse, let's say, underscore, or I don't know, some other toolboxes, the same here. Also, something that is relevant to your question, the Oracleize, which is a service by which you can trigger events in the contract from the outside world. So that's like you can make your contract a bit more alive in terms of if the weather in Amsterdam turns out better, then it can ping the contract and say, oh, it's you should change your status or something like this. And besides of that, there are more libraries that provide useful tools for developers. There's, for example, the Diesel one, again from the same Truffle project, which has a really nice wrapper for apps using Redux. So basically you can have your state partly communicating to a blockchain, those kind of things. So there's numerous improvements and there is a lot of things to learn. Yeah, that was it. Thanks for your time. I hope you have some questions.